Hello everybody, this is Eben, and today I'm going to prove a theorem. So this theorem says that n plus 1 to the n plus 1 power is equal to n plus 1 factorial times the indefinite capital pi of 1 plus 1 over n to the n power. So, at first this looks very, very interesting, because it is. It takes capital pi, it takes factorial, and a number to the power of itself, and even the formula that you can take the limit to infinity of to get the constant e. It takes all of these things and shows how they're related to each other. And this can be proven using the generalized theorem of calculus that I showed in an earlier video. Okay, the first step is to realize that the capital pi of x is equal to x factorial. Capital pi is just the product of a sum. So if you have the capital pi of x squared from the whole way to 3, that's going to be 1 squared times 2 squared times 3 squared. So this can be rewritten as n plus 1 to the n plus 1 power equals capital pi of n plus 1 times the capital pi of 1 plus 1 over n to the n. Now, in much the same way that the summation of f of x plus the summation of g of x is equal to the summation of f of x plus g of x, but summations are a grade 1 operation, so the product would be grade 2. So capital pi of f of x times the capital pi of g of x is equal to the capital pi of f of x times g of x. So this again can be rewritten as n plus 1, n equals the capital pi of n plus 1 times 1 plus 1 over n to the nth power. Now another thing is that if you have some function of that function and it's x with some grade, some interval, and some repetitions of same grade, same interval, and a negative repetition, that's just going to be f of x. So what this is pretty much saying is if you've got two opposite calculus functions, that's just going to come out to the original function. So the opposite of capital pi, as shown in the earlier video, is just f of x over f of x minus 1. So we're going to do this to both sides. So, on this side, there is n plus 1 to the n plus 1 power over n to the n power. And on this side, because they're opposites, that's just going to be n plus 1 times 1 plus 1 over n to the n power. So now we're just going to mainly look at this side. You can take the n plus 1 out, which gives you n plus 1 to the n over n to the n, which you can again simplify to n plus 1 times n plus 1 over n to the n power. And then you can take this fraction and simplify that to get 1 plus 1 over n to the nth power. And this is the same exact thing as this, which shows that this is always true. So an example of this is that 3 to the 3 power is equal to 3 factorial times 1 plus 1 over 2 squared times 1 plus 1 over 1 to the 1 power. And 4 to the 4th power is equal to 4 factorial times 1 plus 1 over 3 cubed times 1 plus 1 over 2 squared times 1 plus 1 over 1 to the 1 power. Because 256 equals 256. And that works for any value of n. Thanks for watching.